Good morning, everyone. I hope I see everyone in good health and you are keeping safe and secure and a good distance from Corona. So, it's after a long time we are meeting, and now we will go on with the new topic, that is resin bonded FDPs. We have enough and more solution for a missing tooth like RPD, FPD. And in FPD, of course, we have the partial retainers and the full veneer restorations. Then, why should we have something like resin bonded FDPs? So, what is the disadvantages of FPD over resin bonded FDPs? So, as you see here, the major disadvantage of conventional FPD is the destruction of tooth structure, which is required for the abutment preparation on which the retainers are placed. Meanwhile, in the resin bonded FDP, it is an alternative to conventional FDP which requires only a very minimal preparation of the abutment. Say we can say that the preparation is limited to the enamel part of the tooth. So much less or minimal preparation is required. So according to GPT-8, the definition for resin bonded FDPs is a process that is luted to the tooth structure, primarily enamel, which has been etched to provide mechanical retention for the resin cement. It was Bunoco in 1955 who described acid etching of the enamel. Ibsen was the first to describe the attachment of the acrylic resin bonding to an unprepared tooth using composite resin bonding. So now we will move on to the classification of resin bonded bridges. It's so important because this topic can be a university question for you either as an essay or a short note. According to the bridges or type of bridges used, it can be Rochet bridge, Maryland bridge, cast mesh bridge, or the Virginia bridge. It can also be classified according to the type of retention. It is classified as mechanical retention, micro-mechanical retention, macroscopic mechanical retention, and chemical bonding. Okay. So we will move on to the mechanical retention. That, as the name says, the retention is purely mechanical. Okay. It is also called cast perforated resin retained FPDs. The example is Rochet bridge. You can see the Rochet bridge here. It was developed in 1973 and it used wing-like retainers. You can see the wing-like retainers here, which has some perforations over here, and these perforations are funnel shaped, which enhances the resin retention. It was introduced principally for the periodontally splinting for periodontally weak tooth. This perforated design becomes the standard for several years, and it is used for both the anterior and posterior FDPs. Howe and Dennehy, they recognized that the metal frameworks improved retention compared to bonded bondings, and they began to use FDPs with cast perforated metal retainers that was bonded to abutment teeth and metal ceramic bondings to replace missing anterior teeth. But they were limited to mandibular teeth or situations where there was minimal occlusal contact. It was bonded with heavily filled composite resin as a luting medium. You can see here, this was the Howe and Dennehy bondings with little or no tooth preparation on the abutment teeth. Leviditis, they replaced posterior teeth. You can see here They used perforated retainers for increasing the resistance and retention. Okay. The castings were the castings were extended interproximally. You can see here it is extended interproximally to the edentulous areas and also to the occlusal surfaces. The design included a defined occluso-gingival path of insertion. It was how can we get a defined occluso-gingival path of insertion? That is by tooth modification. And the tooth modification involved lowering the proximal and lingual height of contour of the enamel on the abutment teeth. But there were certain limitations of this technique, which was weakening of the metal retainer by the perforations, exposure to wear of the resin at the perforations, and limited adhesion of the metal provided by the perforations. Okay, next we will go to the micromechanical retention, or it can also be called as etched cast resin bonded FPDs. Okay, so the micromechanical retention here is provided by the etching of the cast resin part of the bonded FPDs. Okay, and the classic example is Maryland Bridge. Why it is called Maryland Bridge? Because it was first developed at the University of Maryland by Levitis and Thompson. Here it is by the treatment of metal surface with acid and controlled electric current. According to Levitis and Thompson, which they were called Maryland Bridge, they used 3.5% solution of nitric acid with a current of 250 milliampere per centimeter square and the time was 5 minutes, and it was followed by immersion in an 18% hydrochloric acid solution in an ultrasonic cleaner for 10 minutes. All these values are important. You can skip if you don't know the values, and kindly note that don't make mistakes while you are attempting to write all these values. Okay. And this technique, it was specific for non-beryllium nickel chromium alloys. Now, Thomson et al. He used another technique for beryllium containing nickel chromium alloy. He used 10% sulfuric acid at 300 milliampere per centimeter square, which was followed by the same cleaning procedure as it was for Levitis and Thompson. Okay. Dillon et al. They found that the electrochemical etched surface was approximately 2.9 times as retentive as the perforated one. McLaughlin they proposed a much faster technique for etching retainers. It was by immersing them in a beaker of a combined solution of sulfuric acid and hydrochloric acid, placed in an activated ultrasonic cleaner for 99 seconds while a electric current is passed through FPD and the solution. Again, Levitis came forward with a non-electrolytic technique where a nickel chromium beryllium alloy was placed in an etching solution for 1 hour in a water bath at 70 degrees Celsius. Dokadakis, they substituted the electrolytic etching with a form of chemical etching with a stable solution of aqua regia gel. So what was the advantages of etch cast restoration? So the micromechanical method. Here the retention is improved because resin to etched metal bond is stronger than the resin to etched enamel. The retainers can be thinner and still resist the flexing. The oral surface of the cast retainers is highly polished and it resists plaque accumulation. The disadvantages being electrochemical etching is highly technique sensitive Over etching can produce electropolished surfaces, and contamination of surface can reduce the bond strength. So we'll go to the next classification. Sorry, actually it's not a next classification. It's also a type of micro retention, and it's called cast mesh FDPs. It's an alternative technique, and it uses a cast mesh pattern on the internal surface of the retainer. You can see here the mesh pattern, and it is usually made of nylon, and it is adapted to the lingual and proximal surface of the abutments on the working cast. The mesh is then covered by wax or resin, and it is done carefully to prevent occluding the mesh with the pattern material. It is also a technique sensitive, but it can provide adequate retention. You can see the mesh pattern here. Yeah, here you can see the mesh pattern, which can give a good retention. Okay. Yeah. Advantage is that it eliminates the need for etching, and it permits use of noble metal alloys. And the disadvantages: material tends to be stiff, making it difficult to adapt to detail of the abutment too. And if the wax runs too freely into the mesh, blocking out the undercuts, its retentive ability is compromised. The third classification is the macroscopic mechanical retention. So we have completed the mechanical retention, micromechanical retention, and now we are going with macroscopic mechanical retention. And the example is Virginia Bridge. And again, as like our Maryland Bridge, it is called Virginia because it was developed at Virginia Commonwealth University School of Dentistry. The reference surface of the retainer provides the retention here also, and the reference surface is achieved by lost salt technique. On the working cast, the abutment are coated with a model spray and lubricant is applied. Within the outlines of the retainers, specially sized salt crystals of about 150 to 250 microns are sprinkled over the surface in a uniform mono layer, leaving a 0.5 mm border without the crystals at the periphery of the pattern. So we leave 0.5 mm on the periphery, which acts as a border, 0.5 mm border, and all other surface salt crystals are sprinkled. This is followed by the application of resin pattern as usual. After the pattern is inversed, the salt crystals are dissolved from the surface of the pattern. With this method, we can get adequate bond strength. The casting thickness must be increased to allow for the retention layer, and it permits the use of almost any metal ceramic alloys. And the final part of the classification, that is fourth one, is chemical bonding resin bonded FPDs, or they are called adhesion bridges. These resin systems are based on a formulation of methyl methacrylate polymer powder and methyl methacrylate liquid modified with adhesion promoter 4-meta initially. It was developed with unique tri-N-butyl borane catalyst system that was added to the liquid before combining with the powder. We have various systems available now, and one of such systems is Superbond. Superbond is used for base metal alloys, and it has the highest initial bond strength of any adhesive resin system. Advantage of Superbond includes lower elastic modulus, higher fracture toughness in comparison with bis GMA based resin cements. They yield better clinical results with less well adapted castings. Disadvantage being poor clinical results with bonding with high gold content alloy retainers with the abutment teeth. Another system is Panavia. It has shown excellent bond to particle abraded nickel chromium and chromium cobalt alloys, as well as tin plated gold and gold palladium based alloys. It has a tensile bond to etched enamel comparable to the traditional BIS-GMA low film thickness composites. Now we have a recent version of Panavia. It's called Panavia F2.0. It's a dual cure system. That is, it is cured by chemical and visible light. And it can also release fluoride. It also incorporates a self-etching primer system, and it is called ED primer for bonding of enamel and dentin. Another system is Rockatac system. The metal surface is initially particle abraded with 120 microns alumina, followed by abrasion with special silicate particle containing alumina. This second particle abrasion step can deposit a molecular coating of silica and alumina on the alloy surface. Silane is then applied to the surface, making it adhesive to composite resin. Now let's go through the advantages, disadvantages, indications and contraindications of resin bonded FDPs. Advantages being minimal removal of the tooth structure, minimal potential to pulpal damage or trauma. Anesthesia is not generally required as the preparation is confined within the enamel itself. Preparation is always supragingival. Impression making is pretty easy. Interim restoration is not usually required. Reduced chair time, reduced patient expense, and rebonding is possible. Disadvantages: reduced restoration longevity, enamel modification are required, space correction is very difficult, good alignment of abutment teeth is required, aesthetic is compromised on the posterior teeth. Indications: replacement of missing anterior teeth in children and adolescents, short span, unrestored abutments, single posterior teeth, significant crown length, and excellent moisture control. And the contraindications: patients with parafunctional habits, patients having long edentulous spans, restored or damaged abutments, compromised enamel, deep vertical overlap, and patients with nickel allergy. We will stop the session now and will continue the tooth preparation and other part in the resin bonded FPDs in the next session.